first and second mastery assessment. Let us first start off with the introduction of the members.
Hi, I'm Daniela Sadile.
I'm Eliza Cortez.
And I'm Pablo. And today you'll find the mean, median, mode, and standard deviation and create a histogram using the data we have gathered. Let's first start off with the first mastery assessment.
So here in the frequency distribution table, in the first mastery assessment, in the first column, we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30, 31 to 35, and 36 to 40, which is the class range. In the second column, we have 1, 3, 6, 9, 10, 6, and 6, which is the TLE. In the third column, we have the same number as the second column, which is the frequency. And to determine the total number of frequency, we must sum up all the numbers. So the total of frequency is 51.
To find the x sub m, we need to find the middle value or the middle number of the given class range. For example, here in the class range 1 to 5, the middle value of 1 to 5 is 3 because in 1, 2, 3, 4, 5, the middle number is 3. In 6 to 10, it will be 8. 11 to 15 is 13. 16 to 20, 18. 21 to 25, 23. 26 to 30, 28. 31 to 35, 33. And 36 to 40 is 38. Now to find the less than cumulative frequency, we will add the frequencies one by one. So for example, the frequency here in the class range 1 to 5 is 1, so we will just put 1 there because it's the first one. Now in the less than cumulative frequency of 6 to 10, we will have 4 because if we add the recent cumulative frequency, the recent less than cumulative frequency, which is 1, and the frequency of 6 to 10, 1 plus 3 is equal to 4. Then the less than cumulative frequency 4 is added to 6, it will be 10, and 10 plus 9 is 19. 19 plus 10 is 29, 29 plus 10 is 39, 39 plus 6, 45, and 45 plus 6 is 51. Now we will find the f times x sub m. To find the f times x sub m, we will multiply the frequency to the x sub m. Then 1 times 3 is 3, 3 times 8 is 24, 6 times 13 is 78, 9 times 18, 162, 10 times 23 is 230, 10 times 28, 280, and 6 times 33 is 198, and 6 times 38 is 228. And if we add every values of f times x sub m, we will find 1203. Now, for us to move on to x sub m minus the mean, of course, we need to find the mean. So, to find the mean, we have the formula of the mean is equal to the sum of f times x sub m divided by the sum of the frequency, or the n. Then, we will just substitute the values 1203 as the sum of f times x sub m and 51 as the sum of the frequency. 1203 divided by 51 is equal to 23.59. Then our mean is 23.59.
Now, for the x sub m minus the mean, we will take the mean, which is 23.59 in this table, and subtract it to the corresponding x sub m. Starting from 3 minus by 23.59, we will get an equal of negative 20.59. Then next, 8 minus by 23.59 is equals to negative 15.59. 13 minus by 23.59 is equals to negative 10.59. 18 minus by 23.59 is equals to negative 5.59. 23 minus by 23.59 is equals to negative 0.59. 28 minus by 23.59 is equals to 4.41. 33 minus by 23.59 is equals to 9.41. And lastly, 38 minus by 23.59 is equals to 14.41. Now to get the x sub m minus mean squared, we must take the corresponding x sub m minus mean and put it inside the parentheses to make sure the correct integers are given and then squared. Starting off with open and close parentheses negative 20.59 squared, we will get an equal of 423.9481 10,000. Then done the same to negative 15.59 is equals to 243.481 10,000. Negative 10.59 is equals to 112.1481 10,000. Negative 5.59 is equals to 31.2481 10,000. Negative 0.59 is equals to 0.3481 10,000. 4.41 is equals to 19.4481 10,000. 9.41 is equals to 88.5481 10,000. And lastly, 14.41 is equals to 207.6481 10,000. And by summing all our gathered x sub m minus by mean squared, we will get 1,126.3848 10,000. Now to get our frequency multiplied by the square difference of x sub m minus by mean, we will have to take the data we have gathered earlier and multiply it with our corresponding frequency. Starting from 423.9481 10,000 multiplied by its current frequency, 1 is equals to 423.9481 10,000. The next 243.481 10,000 multiplied by 3 is equals to 729.1443 10,000. 112.1481 10,000 multiplied by 6 is equals to 672.8900. 31.2481 10,000 multiplied by 9 is equals to 281.2300. 0.3481 10,000 multiplied by 10 is equals to 3.4800. 19.4481 10,000 multiplied by 10 is equals to 194.4800. 88.5481 10,000 multiplied by 6 is equals to 531.2900. And lastly, 207.6481 10,000 multiplied by 6 is equals to 1,245.8900. And by summing all our gathered frequency multiplied by the square difference of x sub m minus by mean, we will get the sum of 4,082.13500. To find the median, we must first find the median class. We can do that by dividing n to 2, where n represents the total number of frequency, which is 51 in our table. If we divide 51 to 2, we will get 25.5 value. And if we look at our table, we will see the cumulative frequency higher than 25.5 is 29, which is in the same row as the class range as 21 to 25. This means our median class will be 21 to 25. Now, to get our median, we must use the formula below. First, we substitute the values in the formula, where L is the lower limit of median class, which is 21, N is the number of observation or total number of frequencies, which is 51. CF is the cumulative frequency of class preceding the median class, which is 19. F is the frequency of median class, which is 10, and H is the class size, which is 5. After we substitute, we will compute. 51 divided by 2 is 25.5, minus by 19 is equal to 6.5, divided by 10 is 0.65, multiplied by 5 is equals to 3.25, and adding 21 is equals to 24.25. Therefore, our median is 24.25. To find the mode or modal class, we have to look at the most highest frequency at our table. And as we can see, the most highest frequency at the table is 10, which is aligned to both 21 to 25 and 26 to 30. This means our modal class is both 21 to 25 and 26 to 30, which makes our distribution table a bimodal distribution. Next is to find our standard deviation. Using the formula below, we must first substitute the values in it, then compute. 4082.35 divided by 51 is equals to 80.460 10,000s and so on. Square rooted is 8.9468 10,000s, which means our standard deviation is 8.9468 10,000s.
After identifying the mean, median, modal class, and standard deviation, we will now create the histogram. Here's the histogram of this given dataset. To create a histogram, we will need the data of the frequency of each class range or x given. The numbers on the x-axis or at the horizontal line at the bottom are the class range, while the numbers on the y-axis or at the vertical line are the frequencies. As you can see, the class range 1 to 5 is the shortest because it has the lowest frequency, which is 1, and 21 to 25 and 26 to 30 have the frequency of 10, which is why they are the longest. To summarize it all, the results of 51 7th grade students in their first TLE mastery assessment were gathered. As shown in the negatively skewed histogram, the most obtained scores range from 21 to 30, with 10 students getting a score between 21 and 25, and another 10 getting a score between 26 and 30. This means that the mode of this dataset is 21 to 25 and 26 to 30, making it bimodal. Meanwhile, the least obtained score is ranging between 1 and 5, with only one student getting it. Through careful computation, we found that the mean, median, and standard deviation of this dataset are as followed. Mean is equal to 23.59, median is equal to 24.25, and standard deviation is equal to 8.9468.
So here in the frequency distribution table, in the second mastery assessment, in the first column we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30, which is the class range. In the second column, we have 4, 8, 12, 11, 9, and 7, which is the tally. In the third column, we have the same number as the second column, which is the frequency. And to determine the total number of frequency, we must sum up all the numbers. It is similar step to the first frequency distribution table. So the total number of frequency is 51.
Now for the x sub m, we will again find the middle value of a given class range. So the x sub m of 1 to 5 is 3, 6 to 10 is 8, 11 to 15, 13, 16 to 20, 18, 21 to 25, 23, and 26 to 30 is 28. The less than cumulative frequency of 1 to 5 is 4 because we have the frequency 4 and we have nothing to add to it. And the less than cumulative frequency of 6 to 10 is 12 because the recent less than cumulative frequency value, which is 4, added by the frequency of 6 to 10, which is 8. 4 plus 8 is 12. And 12 plus the frequency of 11 to 15, 12 is 24. 24 plus 11 is 35. 35 plus 9 is 44. And 44 plus 7 is 51. And we have the same value as the sum of the frequencies, so we are correct. F times x sub m, where we will just multiply the frequency by the x sub m. So 4 times 3 is 12, 8 times 8 64, 12 times 13 156, 11 times 18 198, 9 times 23 207, and 7 times 28 is 196. Now if we add it all, or the total sum of the f times x sub m is 833. Again, we can't move on to the next table, which is the x sub m minus the mean, unless we have the value of the mean. So the formula for the mean is the mean is equal to the total sum of the f times x sub m divided by the sum of the frequency. If we substitute the values, we will have 833 divided by 51, and we will get 16.33. So our mean is equal to 16.33.
Now for the x sub m minus the mean, we will take the mean, which is 16.33 in this table, and subtract it to the corresponding x sub m. Starting from 3 minus by 16.33, we will get an equal of negative 13.33. Then next, 8 minus by 16.33 is equal to negative 8.33. 13 minus by 16.33 is equal to negative 3.33. 18 minus by 16.33 is equals to 1.67. 23 minus by 16.23 is equals to negative 6.67. And lastly, 28 minus by 16.33 is equals to 11.67. Now, to get the x sub m minus mean squared, we must take the corresponding x sub m minus mean and put it inside the parentheses to make sure the correct integers are given and then squared. Starting off with open and close parentheses negative 13.33 squared, we will get an equal of 177.6889. Then done the same to negative 8.33 is equals to 69.3889. Negative 3.33 is equals to 11.889. 1.67 is equals to 2.7889. 6.67 is equals to 44.4889. And lastly, 11.67 is equals to 136.1889. And by summing all our gathered x sub m minus by mean squared, we will get the sum of 452.6889. Now, to get our frequency multiplied by the square difference of x sub m minus by mean, we will have to take the data we have gathered earlier and multiply it with our corresponding frequency. Starting for 177.6889 multiplied by 4 is equals to 710.7556. Then next is 69.3889 multiplied by 8 is equals to 555.1112. 11.889 multiplied by 12 is equals to 133.700. 2.7889 multiplied by 11 is equals to 30.6800. 44.4889 multiplied by 9 is equals to 400.4300. And lastly, 136.1889 multiplied by 7 is equals to 953.3300. And by summing all our gathered frequency multiplied by the square difference of x sub m minus by mean, we will get the sum of 2783.3300. To find our median, we must first find the median class. Again, we can do that by dividing n to 2, where n represents the total number of frequency, which is 51 in our table. If we divide 51 to 2, we will get 25.5 value. And if we look at our table, we will see the cumulative frequency higher than 25.5 is 35, which is in the same row as the class range 16 to 20. Meaning to say, our median class will be 16 to 20. Again, to get our median, we will use the formula below. First, we substitute the values in the formula, where L is the lower limit of the median class, which is 16, N is the number of observation or total number of frequency, which is 51, CF is the cumulative frequency of class preceding the median class, which is 24, F is the frequency of median class, which is 9, and H is the class size, which is 5. After we substitute, we will compute. 51 divided by 2 is 25.5, minus by 24 is equals to 1.5, divided by 9 is 0.166, multiplied by 5 is equals to 0.83, and adding 16 is equals to 16.83. Therefore, our median is 16.83. To find the mode or modal class, we have to look at the most highest frequency at our table again. And as we can see here, the most highest frequency at the table is 12, which is aligned to 11 to 15, making our model class 11 to 15. Next is to find our standard deviation. Again, using our formula below, we must first substitute the values in it, then compute. 2783.33 divided by 51 is equals to 54.5750 10,000s and so on. Square rooted is 7.3875 10,000s, making our standard deviation 7.3875 10,000s.
Now, after performing the 4 steps required for our findings, we will now create a histogram. I've already discussed how to create a histogram in the previous example, so we will now just find the class range with the lowest and highest frequency. So, in this given data set, the class range with the lowest frequency or the shortest class range in the histogram is the 1 to 5 with the frequency 4, and 11 to 15 has the highest frequency with the frequency 12. To summarize our findings, the results of 51 7th grade students in their second TLE mastery assessment were gathered. As shown in the positively skewed histogram, the most obtained scores range from 11 to 15, with 12 students getting it. This means that the mode of this dataset is 11 to 15. Meanwhile, the least obtained score is ranging between 1 and 5, with 4 students getting it. Through careful computation, we found that the mean, median, and standard deviation of this dataset are as followed. The mean is equal to 16.33, the median is 16.83, and the standard deviation is equal to 7.3875.
And that is the end of our presentation. Thank you for listening.